This is the file that's on our GitHub. Is it big enough to read?
Maybe one more. I'll take a look at the chat if anyone complains.
Okay, we'll be safe. Yeah, so. Okay, so we just load in, we only have a couple packages to load today. So we'll have our tidyverse package, and I'll be talking about some ways that you can do annotations with base Ggplot without really needing any other packages. And then later, Julia will tell us about the packages Ggfx and Ggforce, which also allow you to do cool things with annotations. So we loaded those in. And of course, we need a plot to play with in order to show the annotations. And we're taking here a Tidy Tuesday dataset, which focuses on transit costs. So it shows different public transportation lines, how long they are, how much they cost, where they're located, and so on. So we'll read it in here from the Tidy Tuesday repo. And we do just a little bit of wrangling here. So we're giving these countries like full names instead of their country codes that they had before. But you can see that there's all different countries, the cities, the name of the line, when it began construction, when it ended construction. Some of these variables we won't really use, like how many tunnels there are, but we will be looking at the cost and also how long the line is. So we've also narrowed this down to just 5 countries to make it a little bit easier to graph. So we look at the 2 countries with the highest cost per kilometer built, which are the US and Vietnam, and the 2 with the lowest cost per kilometer, which are Spain and South Korea, and then China, which is the country with the most projects overall. So we'll create our plot. This is a plot that actually Julia made for the chart challenge. So it's a variation of, or that's what we're using kind of as our inspiration. And this is a pretty big code, but basically we are plotting one scatter plot of all of the different lines by their length and their cost. And we're just subsetting to these 5 countries. So first we're doing a little scatter plot, so I can just walk you through.
I think you need to include the size, like one more line. Otherwise, it's not fully closed, and then it complains. And now it might complain because, yeah, just do it again. Yeah, there you go.
Okay. So anyway, here are all of the overall points. So we start with a scatter plot by country, where we have the different lines and their price by length. And then we add these 2, back up here. These 2 trend lines. So one is a trend line for each individual country of the 5 countries that we selected. And then we put in also a trend line for all of the countries in the entire data set. Let's see if I can get this correct. Yeah. Yeah, so we have a little bit of an axis problem here, which we'll fix in the next step, but you'll be able to see in a minute these like individual trend lines and then these scatter plot lines. So we fix the axis limits and set the breaks. We add some custom colors and some labels here, and then just like a little bit of theme. And when we do this, it looks long, but it's really quite simple. Well, hopefully it's readable. But now you see this is our plot that we'll start with. So it's got all of the individual points as dots. They're color coded by country in these nice custom colors. And then we have a line for each of the countries, which shows the trend for that country. And then this dotted black line is the overall trend for all the countries in the data set, going beyond just these 5 data sets. These 5 countries. Okay, so that's the graph that we'll start with. And now we want to see what kind of annotations we can add to it. And the first things I'm going to show you are all base Ggplot annotate commands, which is cool. So you don't have to load in any other packages to be able to do this kind of annotation. So maybe before we show that, is there any questions about the plot?
I don't see any questions, but maybe you could scroll back up to the subset, because I'm not sure if people are very familiar with that.
Yeah, okay. So what we've done here is, so we haven't given the overall ggplot call a data like we might normally do. So very often maybe you'd start your ggplot call and just right away define the data for the upcoming plot. But we have kind of two different data sets that we want to use. So for the points, we only want the data to include these 5 countries. And for the individual country trend lines, we only want these 5 countries. But when we write this line, which is the overall trend for all data, we want to go back to the original data set. So in order to do that, we call the full data set down here in the overall trend line geom. But in these two geoms, the points and the individual country trend lines, instead of calling the whole data set, we use subset directly within Ggplot. So you can subset this, the first argument is the data, and the second argument is kind of like your filter condition. So here we filtered that the country column shows up in this list. So it's one of these 5 options. And then by doing that, so each geom is kind of getting its own data. And that's what allows you to have the points and the lines just from these 5 countries, while the overall trend line represents all the countries. Is that clear?
Yeah, thanks.
Okay. Great, so this is our plot. And let's do some annotation. So we're going to use this annotate command, which, like I said, is a ggplot command, actually. And we want to do this by, so first let's start with like explaining what this black line is, this dotted black line. So we know this is the overall trend for all the data in the entire data set. But let's describe that. So we have our trains plot. So we've saved that to the name train. So that's still the same old plot that we had before. And then we can add plus annotate. Here we're going to set geom equal to text. That's one of a couple options that you can use for adding annotations in base ggplot. And this, as you would expect, just adds text. So there's no box around it. It's just will just be text. And then we set where we want the annotation to appear. And these are on the scale that we have in the graph. So we want at the x position 13,000 and the y position 35. So 13,000 and 35, let's scroll down. So that would be around here on the x-axis and around here, 35. So it really depends on the scale that you have on your data or on your axes. So we're going to place it at 13,035. You can set the size of the text, the color. You can set how close together the lines of text are. So here we've just made them just a little bit closer together. And then there's the argument label, and that's where you give the text that you want to show up. So you set the geom, you set where you want it to be. You can change some things about how the text reads, and then you give the actual text on the label. So I'll scroll down. So you can see, well, with some of these, it's going to look a little bit better if we pop it out. So let me change my screen share. I'll do like this. Okay, now you can see this pop up, right? No?
Yeah, we can see it. We can see it.
Okay. It's actually. Okay, we'll go back to this. So basically this looks a little bit big right now, and on my screen it's not really playing well with me because I have it kind of zoomed in, but you have to imagine that this does fit when you actually export this graph. And I see that you get the idea that the text shows up in the location, so kind of centered on the location that you've given, right? So like the first word does not show up at the point that you've selected, but it centers around that point. Okay, so that's how you add just plain text to your plot. And then another option that you have just built in with this annotate function is to draw like a rectangle around certain points that you want to emphasize. And so because a rectangle, of course, has like 4 corners, you have to give 4 positions. You give the x min and the x max, which will be where the box kind of starts on the x-axis and then where it ends. So this one will go from 1,000 here to about 11,500 but here. And then of course you have to also give the height. So this one will start at 0, it'll start right down here on the x-axis and it will go up to 20. So just the same as the text geom, you can see that these locations are given based on the scale that you have on your graph. And then the only other argument or that you see here is alpha. You may recognize that from Ggplot other things, but it's just transparency. So we're going to make this to an alpha of 0.2, and that's going to make it relatively transparent. So if we run that, you can see that now the rectangle is located in those points that we've given, and it's pretty see-through. So going to a lower decimal is going to make it more see-through. And going to a higher decimal or all the way up to 1 is going to make it more opaque, which is just the way that alpha works in your base geoms as well. There's a couple other geoms that we didn't cover. There's one for segment, which will draw a line, and there's one for a point range. But we'll show you later how to do things like arrows. But if you're interested in those, you can check those out as well. Okay, is there questions on this before? So we have a little exercise that you can try it out. Are there any questions on this?
I don't see any questions right now.
Okay. Then you can go ahead and take a minute to try this little exercise. So it's just to try out adding another text annotation in a certain position. So I'll give you a few minutes to try that, and then we'll go over how we solved it. So arrows we can add with a geom called geom curve. And we can do this to kind of connect text annotations to like the lines that we're referring to. And so let's take a look. So here we have, again, the plot that we've already made. And we can add just plus geom curve. And so the aesthetics that you have to give here are like an X starting position and an X ending position, and a Y starting position and a Y ending position. So this is a little bit like the rectangle, except for instead of the rectangle, you're going to get like an arrow that goes through the middle of those points from this point to this point. Then you have an argument for arrow, which takes an arrow object. And here the length is the length of the like lines that make up the arrow. I'll play with that in a minute so you can see what that does. And then you can set the size and a color, and you can set a curvature for it. So let's look at it, and then I'll change some arguments so we can see how they work. So this is the arrow we have right now. I've made it red. It's a little bit stumpy down here, so it looks like it should probably be going up a little bit higher on the y-axis, for example. So we could have the y end, right now it's at 44, and maybe we want to take it up to like 52. Yeah, so you can play around with that to get it to look just right. But basically you can also change, so for example, if we make this to 0.2, so I'll show you that code again in a second. Then you can see that I've made the kind of pointy bits of the arrow really long. That was here in this arrow object. So we had it at 0.1. You can set the units, it can be like centimeters and I think also pixels. But that just changes like how long of an arrow is on the top of the line. You can also change the size, which will be like the thickness of the line. So now we've got kind of a more chunky arrow by changing the size. And you can change the curvature. So 0 would be like a straight line. If you give a negative number, it's going to curve to the left. And if you give a positive number, it's going to curve to the right. So if you give it a 0, it's going to be totally straight from point A to point B. You can also, so we had it at 0.5, but for example, if you give it the argument 0.2, then it will be just a little bit curved. So you can really like fine tune how long the arrow is, how long the little hat of the arrow is, how thick it is, how curved it is, and you can change the color. Yeah, pretty easily. And again, this is the same kind of a thing where the positions are on the scale of your axes. So if you want, what if you want to add a couple arrows at the same time and you don't want to write this out every time? You can make a little data set, so a little tibble, which contains all of these arguments, and you can feed them all into your ggplot at once. So you remember we have the arguments x, y, x end, and y end. So we're going to call this x1, this x2, this y1, and this y2. That's just kind of what we went with, but you could call it actually whatever you want as long as you're consistent later in the code. But we make a little tibble, and we make 4 columns, one for the x start, the x end, the y start, and the y end. So again, that's what we've called them, x1, x2, and y1 and y2. And you can give in the values that you want for these arrows. So we're going to make 3 arrows. And everything that's kind of in a column belongs to the same arrow. So let's run this and just take a look at the data frame. So we're going to have one arrow that starts at 8,000 and goes to 8,000. Okay, that's what we have. And goes from 10 to 6 on the y-axis. Then we have this next one, which is 13,500 to 13,200, and going from 38 to 55 vertically. And the third arrow. So all we've done is just like taken those arrows, like the arguments that we would have needed to feed for those arrows, and put them into a little data set. And we've called this data set, or it's a tibble, we've called it arrows. And now when we add this geom curve to our plot, we can set the data equal to arrows, which is the new tibble. And then we can set these arguments that we had to give above, like x, y, and x end and y end, to the names of the columns where that information is contained in the arrows data set. So you could have also called this y and this y end, or you could call it anything, any variable name, but as long as you know which ones to map to which. Now the rest here is kind of the same as what we had before. You set the arrow as an arrow object, which gives the length of the tip, the thickness, the color, and the curve. These aren't the exact same that we had above, but you get the idea. And now we have 3 arrows, so they're a little bit hard to see, so let me just put them in red for now. But now we have 3 arrows. I don't know why we made this one so short, but you can get the idea of how you can make these. Yeah, this one's a little bit short, I think because of the weird preview that we're seeing here. But the idea is that you, yeah.
Sorry to interrupt. Sometimes, like for me, it's sometimes better to copy paste the code in the console and then full screen it. You know what I mean? Put it in there. That sometimes works better. Some of these annotations don't play super well with Markdown for some reason.
Yeah, I'm partially being a little bit lazy because when I share the screen, I have to change my screen share.
Oh no, okay, never mind.
Like it doesn't pop up in the R Markdown.
All right.
But you can check it out on your own. So let's see if it will load for me. Endpoints must not be identical. Maybe this is the problem. Okay, if you get that error that endpoints must be identical, I don't know, maybe we had a typo there, but I can try and do this in the full screen just to show you. Yeah, so it does look better that way. Here. So there's a little bit, so now you can see that the arrows do make sense where they're located. And this you can also pay attention to. Just make sure when you're playing with annotations that you pay attention when you like Gg save or you save your Ggplot to a JPEG or something, that you look at the dimensions and you preview to make sure that the arrows end where they are supposed to end. So if you mess with the dimensions of the plot, sometimes it messes it up a little bit. Seems to be minor, it's not major, but they might not be in the exact right spot. Okay, let's hop back to our studio. Yes, so that's how you make arrows right here within Ggplot without needing any other packages. And now we have another little exercise for you to try adding an additional arrow to the plot that we're working with. Are there any questions before we take a minute to do that?
I don't see any questions.
All right, then I'll give you a minute.
Oh, sorry.
I have a question that's not, if I can interrupt, that's not arrow related. It's about a parenthesis.
And could you make that a bit bigger, Yulia?
Oh, yeah. I will do in a second. Just looking at something else. Okay. How's that?
For me, it'd be better just a tiny bit bigger still. I'm
Oh,
on
wow.
quite a
Okay.
small screen.
I can, that's fine. I can do that.
Yeah.
Okay. Okay, great. All right. So what Kyla has shown us has all been using Ggplot commands. So up until now, you didn't really need any other package for this. But now we'll show you 2 additional packages that you can use. So Ggforce will do that first, and that will also let you annotate your data like we have been doing, so kind of labeling it within the plot. And then Ggfx is a package that has a bunch of different filters. So filters, you can really think of that a little bit like Photoshop. So what we'll do is blurring and zooming in. It has a bunch of other filters as well, but the ones that I'm familiar with and the ones that I think make sense for kind of these kinds of data visualizations are blurring and zooming in. But first, Ggforce. And we'll use a different data set here. And this is a data set that you might already know. It's another Tidy Tuesday one with data on different films. And if they pass the Bechdel test, so the Bechdel test is, are there at least two named female characters in a film? Do they talk to each other? And when they talk to each other, is it not about a man, but about any other topic? So you would think that's a pretty low bar, but as you'll see in a second, there are still plenty of films who kind of fail that test. So I've read that in, here I've already run that because it's a pretty big data set. I'm just cleaning up a couple of things. So there were some weird, I think, faulty read-in symbols that I'm just replacing. I'm changing some data types as numeric. I'm changing the format of this number, dropping cases where people weren't sure if they pass or fail the Bechdel test, dropping missing values, and then also recoding the clean test variable just so that the names are a little bit more easier to understand. Okay, and then I've created a plot here, and I can just show you that. Okay. So here, I'll make that a bit smaller, hopefully you can see it. Okay, so here we have, on the x-axis, we have the year that the film was published. On the y-axis, we have the budget in million. That's why I was kind of dividing it, so I could just write in million. And then the color tells you whether the film passed or failed the Bechdel test, and kind of on which level, right? So do we have female characters, but they only talk about men? That would be orange, for example. Okay. And we'll make another really quick, really simple plot just because it's useful to show you what's going on. So these are the Parma penguins that you've probably used a bunch of times. So these are these 3 penguin species, and we'll just make a really simple, not very pretty plot, but we'll just need it for a bit. Bill length and bill depth. And the reason why I'm using that is for, as you'll see in a second, it's really nice how the data points are almost separated by species, and that'll make it easier to show you a couple of things. But we won't use that a lot because we've been kind of overusing it. So now, what can Ggforce do? So we have a couple of new geoms that it introduces. So we have this geom mark and then something, so geom mark family kind of, and that will enclose a group of data points in specific shapes, right? So I'll just show you an example. So we're making this penguins plot or a similar plot again, and here we have geom point. As we've had before, we're not doing the trend lines, but instead we're doing geom mark circle, and the aesthetics will be fill equals species. And what that does, and here I'll actually copy paste it in the console and then zoom in. So kind of do this because it really doesn't show up super well in Markdown. What it does is it draws a circle around each species of penguin. So that's the fill species argument, and it draws a circle around each of these different species, and color codes it as well. And as you can see here, this is not, circle is probably not a good shape, but we'll just go through and we'll show you what they each look like. You can do a rectangular shape. Oops, let me try that again. Sometimes it doesn't want to show up straight away. We're doing it here, so rectangles probably also not that great for the shape that the data is in. Then we have hull, do that next. Yeah, I'll do a lot of copy and pasting. I hope that's okay, but it just shows up much more nicely in this Zoom window. So geom hull, that makes a shape that really shows you pretty well what the outline is, right? So really just drawing a shape around the data points that belong to one group. So that's geom hull. For that, you need an additional package, Concaveman. So if you try that, it might complain that you need that package and you just need to install it. You don't need to load it in case that happens. And then we have ellipse, last but not least. Oh, once again, I'll copy paste it. That's probably better. Okay, so you can see now we have these ellipse shapes drawn around each group. Okay, and here, so let me try and take this drop NA command out. Yeah, so you need to make sure that there are no missing values in your variables here. So in these 2 numeric variables, if you have missing values, it'll give you this error, right? So that's why I have a drop NA. So if there are missing values in either bill length or bill depth, those rows will be removed before plotting. And this is different from Ggplot. Ggplot will just tell you, oh, I've removed a couple of missing values, but this package needs you to remove it. Otherwise, it'll complain. And this is the error message that you get. So if you get that, you probably have missing values. Okay, so within all these geoms, you can tell Ggplot or Ggforce what kind of a label and what kind of a description you would like. So far we still have a legend on one side, but we can also label it directly in the plot. So here I'm using geom mark ellipse again, and in the aesthetics, fill equals species, we've had that before. So just draw separate circles or ellipses around each species, penguin species. And then in label, so label will be a little bit bigger, description will be a little bit smaller underneath it. Label I'm taking from the data, so label equals species, so we just want the specific species to be named here. And then description, I'm just typing in penguin species just as an example. You can, for both of these, you can type something in quotation marks, or you can refer to the data, and I'll show you another example in a second, but this one first. So again, I'm going to copy paste it. Okay. I'm going to reload it because this is Yeah, this is what tends to happen with this package. Okay, so first of all, let me explain what we're actually seeing. So we now have a little line that connects from one of the ellipses and then is labeled. So these are the Adelie species. And then penguin species is that text that I entered. And same happens for this green circle. And then you can see the blue one isn't labeled. And that is because I'm zoomed in so much. I think that's what it is, at least. And so you can see that this package makes really nice plots, but it also is a little bit fiddly. Yeah, now you can see that it worked, right? But it can also be a little bit fiddly depending on how far you've zoomed in. And another option to deal with that would be to make the text smaller. I'll show you in a second how that works. But the general idea is, so you have these geom mark and then whatever shape you want. And then you have label and description. Label is a bit bigger, a bit bold, and description is a bit smaller, and it's connected. So there's a line connecting it to the circle or ellipse or whatever you've picked as a shape. And that's a bit, yeah, similar to what we've been doing with this text box and then an arrow pointing to a line or a data point. And it just does it automatically. It looks very nice. You don't have to worry about figuring out the right X and Y coordinates, but it's also a little bit sensitive to how far you've zoomed in. Okay, so now for this, I'll just show you the plot again before we do anything with it. So this is our, I'm going to try and show you the plot again at least. This is the Bechdel test plot again that we've made. And now we'd like to just filter out 4 of these high data points, 1 from each category maybe. And we would like them to have a little circle around them and then a line connecting to a label with the film title. And then the data frame also has a column with the film's plot in it, a really quick 2 or something sentence plot summary. And we would like that to show up in the plot. I mean, we have a lot of white space here. We might as well fill that with something. So because we only want that to happen for a couple of films, like obviously we don't want that, we don't want descriptions for all of these points. That would be pretty crowded. We need a filter here. So I've picked out these 4, I've played around with the data and picked out these 4 film titles. So here I'm using geomark circle. Label is the title, so that's going to be the film title. And then I'm filtering. I'm saying title should be in, and then I'm giving a vector of these 4 film titles. And then description should be plot. So plot is a column in the data. Okay, I'll run that. I'll explain the rest in a second, but just so you see. Okay, and you can see what I mean, right? So because there's not a lot of space here, it's trying to do it, but it doesn't have a lot of space in this preview window. So again, I'm going to copy paste it in the console down here and then zoom in. And now you can see that it worked. Right, so now we have these 4 films that I've picked out. They each have a circle around them in the same color also, which looks nice, I think. And then you have, so the title and then the plot description underneath it, and it's a bit smaller. So that's the idea here. So the additional arguments here, so label line height, we've seen that. So that's just how close is the text together when we have several lines. So how squished is it? Label font size, so that lets you set the font. And this is a vector because we have font size 8 for the label and 6 for the description. So avatar would be 8 and then the plot summary would be 6. So that's why you have a vector, because you can set that differently for these two elements. Show legend false is just not showing the legend for these 4 points. It would add another legend, which we don't want. And then expand. Expand is how much space do you have between the point and the circle. So let me make that pretty small so you can see that, how that changes. Okay, so you can see now that the circle is pretty close to the point. Right, and you can see also that it's a little bit difficult to, get it to show up perfectly. So you might need to kind of have to play around with it a bit. All right. Okay, so I have an exercise here, but are there any questions before we do that?
There's a question about why, when it went smaller, the points were actually not centered.
Yeah, that's a good question. I don't know.
Yeah.
I would like to know that as well. I'm not quite sure what's going on. On there.
I think there's also always this trade-off with these packages between like either you have to set it yourself or you have to let it pick whatever it thinks is the best default standard, which is also why sometimes when there's no space, it just doesn't print the labels because it can't really find the space.
Exactly. Yeah, it's kind of a convenience trade-off with, you have to program more by hand, or it's more convenient, but maybe a little bit harder to control, and obviously, so yeah.
There's also a question about how you selected or identified those 4 films to circle.
Don't remember, honestly. I think I probably did a group by the Bechdel test variable, because I wanted one from each, and then did a slice max to find the one with the highest budget, or one of the highest budgets. I think that's what I did. I think I did group by, clean test is the variable, and then I did slice max. Probably. Or maybe I just filtered by budget and year and clean test. Okay, so the exercise or exercise suggestion is trying to label this blue point and trying to label the yellow point, the yellow dot between this one, 1975 and 1980. That would be a suggestion. So just try to label some other points. You can also pick different ones if you're interested in a different point. On worked partially. Okay. I think that's fine for now. Okay. In that case, we can move on to the Ggfx package. So this is a package that has filters. So filters really similar to like a program like GIMP, where you can blur elements, and that's what we'll do. So it has a bunch of different filters. Here's a blog post which is titled "Say Goodbye to Good Taste," because you can really do kind of awful looking things with it. So this with blur command that it has, I think that's useful for data visualization, because what it does is we can blur data from other groups and leave just one group unblurred, so to draw attention to it. So the way we'll do that, so this is again with this the Bechdel test data, so similar plot, and we want all the points, so this is a scatter plot, we want the points to be kind of blurry, have a little bit of a blur on them, except the data points that are from this that are red in our plot, so that point to films that have no named female characters. So the way we do that is up to here, everything's normal, right? We have the aesthetics as we usually would. And then we're using geom jitter again. So this is just for the scatter plot. That's our usual geom, but we're wrapping it into with blur. So we're writing with blur, opening brackets here. And then geom jitter. And then this is an additional setting for with blur, which just specifies how much blur we want. So that's the sigma argument. It's just how blurry should it be. So at this point, let me see if I can just run it up to here. Yeah, let's see. Let's try that again. Okay, so at this point, we have all blurry data points, right? So all the data points we have are blurred now. The colors are off and everything because we do that later, but yeah, all the data points are blurred right now because we've added with blur around it. So now we want to add, or kind of add on top the data points that should not be blurred. right? And to do that, we're adding another geom jitter. Data is from the same data frame, but then we're filtering it to say clean test. So this clean test column should say no named female characters. And because this is just a normal geom jitter, not with blur, like the with blur ends here, that's just this part, it'll plot these on top and they won't be blurred. So let me run it, and there you go. Okay, so now everything's blurred in the background, and just the red points, which are a film doesn't have named female characters, these are shown clearly, and the rest is blurred in the background. Okay. So you can blur data points. You can also blur other plot elements. So this is going to be in theme. For example, the caption. We can say plot caption equals, and then we need, again, with blur, element text. So element text is what we would use anyway for plot caption because it is a text element. And then this sigma is, again, how blurry it should be. Maybe we go back to this plot for a second and just play around with it a little bit. So we can make it a pretty small number. And you can see they're barely blurred, right? They're just a little bit blurred. And if we make it even bigger, they're really blurred, right? You can barely see them now. So I think what we had was something in between those two. Oops. Yeah. So you can still make out the points, but they're quite blurry, and your attention is drawn to these red points. Okay.
And Julia, so where you have that filter command, that could have also been a subset command like we did earlier.
Yes, that could have been a subset. This is a bit more tidyverse. Subset is a bit more base R, right?
Mm-hmm.
But both of them work the same way.
Mm-hmm. And you also could have made an additional data set that includes those and saved it to a name and then read that in with the as the data.
Exactly. Yeah. Mm-hmm. Absolutely. Yeah. Okay. Yeah. So then we're going to blur the caption just to see what it looks like. And you can see this is a bit blurred now. Or we can do the same with the legend. So same idea, just in theme, legend text with blur, and then element text, and then sigma is just how blurred it should be. This is probably more of so this kind of blurring text is maybe more of a didactic thing, right? Where you have, you do want to show people the clear plot probably at some point, but it's kind of fun to be able to blur text and maybe have people guess what it says behind the blur. Maybe you need to do it a bit more extremely like this so people really can't guess very well. Okay, so you can apply that to data, but you can also apply it to these text elements. All right, and then one more thing I wanted to show you from this package is Facet Zoom. So this lets you zoom in on a group or a range of data points. So here we're going back to this transit cost data set. We're making a very simple plot just to show what's going on. So this is not going to be the prettiest plot, but you'll see what's going on. So here we're filtering to the countries we're interested in, and we're just making a scatter plot of cost by length, separate for these countries, like we've been doing before. But then this last line is interesting. So then we're saying on the x-axis, zoom in so that the data points from a specific country are shown, and the country should be Spain. I'll just show you what that looks like. Okay, so you can see on top you have the entire plot. Again, bit of an ugly version of it, but just because I wanted to show you a facet zoom. And then you can see that it kind of connects to the zoomed in plot. And this zooms into where the data points from Spain are, which is that kind of olive color by default. So it cuts off at 8,000, right? Because that's where all the data points are situated, because we said on the x-axis, zoom into just where Spain has some data points, right? So you have the full plot and then this facet zoom additionally. And we said do that for the x-axis, and for kind of a categorical variable, a factor for Spain. You can also do that on the y-axis. So here, same plot, and we're doing a facet zoom, which is on the y-axis this time, and it's numeric this time, right? It's just to show you that that works too. So show a plot that cuts off at the y-axis at 20, so just the shorter lines. So let me run that. Okay, so you can see now we have the full plot on the right. This is the full plot. It's a bit squished. And we have zoomed out this plot that stops on the y-axis at 20 and just zooms in on this part of the data. Okay, so this works on the x-axis or on the y-axis. It works with kind of logical matching, so with these two equal signs. And it also works with this numeric matching, bigger or smaller than, right? So you might know that from filter commands. So it's the same logic and the same syntax here. Okay. And then we have a final little exercise, 2 parts if you're interested. So this is again with this trains plot that I've been showing here, right? And one idea would be to blur the individual data points, but leave the trend lines as they are. So don't blur those. Or you could so leave the data points from the US and Vietnam unblurred and blur everything else. So to kind of emphasize the data points from these 2 countries. 2 ideas, you can try one or both if you have time, if you feel like it. And I've just pasted the code from the original plot because it's easiest to just add to that code.